Case study, Revolutionizing Cybersecurity with Natural Language Processing, a case study of advanced threat detection at CyberGuard. NLP is revolutionizing cybersecurity by enabling advanced threat detection and automating responses to incidents. In a cybersecurity firm named CyberGuard, the integration of NLP into their operations marked a turning point. Located in the heart of Silicon Valley, CyberGuard was known for its innovative approach to tackling emerging cyber threats. The team, led by seasoned cybersecurity expert Dr. Emily Stone, was on the brink of launching a new project leveraging NLP to enhance their threat detection capabilities. Dr. Stone, along with her team comprising data scientists, cybersecurity analysts, and machine learning engineers, embarked on this ambitious project. They aimed to integrate NLP into their security information and event management systems to analyze unstructured data from various sources, including social media, forums, and blogs. This integration would allow them to identify potential threats and vulnerabilities in real time. The first task was to implement tokenization, a critical step in NLP that involves breaking down a text into smaller units like words or phrases. By doing so, the team could analyze the vast amounts of data more efficiently. One day, while reviewing an unstructured data feed from a popular tech forum, Dr. Stone noticed a surge in discussions about a new type of ransomware. How could the team utilize tokenization to parse through this forum data to identify relevant threats? Tokenization allowed the team to break down the forum posts into individual words and phrases, making it easier to identify patterns and keywords associated with ransomware. Using these tokens, they could flag any posts that contained specific terms related to ransomware attacks. This preliminary analysis was crucial in narrowing down potential threats from a sea of unstructured data. Next, the team moved on to part-of-speech tagging, which involves labeling each token with its corresponding part of speech, such as nouns, verbs, or adjectives. This step was vital for understanding the context of the words in the text. For instance, identifying whether the term attack was used as a noun or a verb could provide insights into the nature of the threat. What are some challenges that might arise during part-of-speech tagging in cybersecurity data, and how can they be addressed? Part-of-speech tagging in cybersecurity data can be challenging due to the presence of jargon and technical terms that may not be present in standard language models. To address this, the team customized their part-of-speech tagging algorithms to recognize specific cybersecurity terminologies. By training their models on annotated datasets from previous cyber incidents, they improved the accuracy of their tagging system, ensuring a more precise understanding of the context. Named entity recognition was the next task, where the algorithm identifies and classifies entities mentioned in the text into predefined categories such as names of persons, organizations, or locations. This step was crucial for pinpointing specific threats and their origins. For example, identifying the name of a new ransomware variant or the organization behind a cyber attack could provide valuable intelligence. How can NER be leveraged to enhance threat intelligence in cybersecurity? NER was employed to scan through vast amounts of text to identify and classify entities related to cyber threats. By recognizing specific ransomware names or hacker group aliases, the team could gather actionable intelligence. This information was then cross-referenced with existing threat databases to assess the credibility and severity of the threats. The ability to quickly identify and classify these entities significantly enhanced their threat intelligence capabilities. Sentiment analysis was another important task, aiming to determine the underlying sentiment or emotional tone of the text. This analysis was particularly useful in monitoring social media for potential cyber threats. For instance, a spike in negative sentiment towards a particular company could indicate an impending cyber attack. How might sentiment analysis assist in predicting and preventing cyber attacks? Using sentiment analysis, the team monitored social media platforms for negative sentiments towards their clients. An increase in negative posts often correlated with planned cyber attacks, providing a crucial early warning. By detecting these sentiments, CyberGuard could proactively reinforce their clients' defenses, mitigating potential attacks before they occurred. Machine translation played a key role in understanding threats originating from non-English sources. With cyber threats becoming increasingly global, it was essential to translate text from various languages while preserving its meaning and context. How can machine translation contribute to a more comprehensive threat detection strategy? Machine translation enabled the team to analyze cyber threat intelligence from around the world, breaking down language barriers. By translating foreign language texts into English, they could integrate this information into their existing threat detection framework. This comprehensive approach ensured that no potential threats were overlooked due to language constraints. The development of sophisticated algorithms was underpinned by various theoretical models. One foundational model was the bag of words approach, which represents text as an unordered collection of words, disregarding grammar and word order, but keeping multiplicity. While effective for text classification and information retrieval, BAW had limitations, such as ignoring word context and semantics. What are the potential drawbacks of using the BAU model in cybersecurity, and how can they be mitigated? The BAU model's main drawback was its inability to capture the context and semantics of the words, which are critical in understanding cyber threats accurately. To mitigate this, the team employed more advanced models like word embeddings. Word embeddings map words into high-dimensional vectors based on their context within a corpus, capturing semantic relationships between words. By using word embeddings, they could better understand the nuances of the text, enhancing their threat detection capabilities. Recurrent neural networks, particularly long short-term memory networks, were instrumental in handling sequential data and capturing long-range dependencies in text. LSTMs were deployed to process temporal data, such as security logs, where the order of events was crucial. How do LSTM networks address the challenges of processing sequential data in cybersecurity logs? LSTM networks were adept at retaining information over longer sequences, making them ideal for processing security logs. By analyzing the sequential data, the team could identify patterns and anomalies that indicated potential threats. LSTM's ability to capture long-range dependencies allowed them to detect sophisticated attacks that spanned multiple stages, providing a comprehensive analysis of the security logs. The introduction of transformer models, leveraging self-attention mechanisms to process text in parallel, revolutionized NLP. Transformers significantly improved computational efficiency and performance on various NLP tasks. The bidirectional encoder representations from Transformers model, developed by Google, set new benchmarks by pre-training on large corpora and fine-tuning on specific tasks. How do transformer models like BERT enhance the analysis of cybersecurity data? Transformer models like BERT enhance the analysis of cybersecurity data by allowing the team to process large volumes of text efficiently. BERT's bidirectional approach enabled it to understand the context of a word based on both its preceding and following words. This deep contextual understanding improved the accuracy of threat detection and classification, making BERT an invaluable tool in CyberGuard's NLP toolkit. Despite the numerous advantages of NLP in cybersecurity, the team encountered several challenges. One significant challenge was the ambiguity and variability of natural language. Different individuals use different terms to describe the same concept, making it difficult for NLP algorithms to interpret and categorize the data accurately. How can the variability of natural language be managed to enhance the effectiveness of NLP algorithms in cybersecurity? To manage the variability of natural language, the team implemented a robust pre-processing pipeline that included synonym recognition and normalization techniques. By mapping different terms to a standardized vocabulary, they reduced ambiguity and improved the consistency of the data. Continuous updates to the vocabulary ensured that the algorithms kept pace with evolving language trends in cybersecurity. Another challenge was the need for large annotated datasets for training NLP models. Annotating data was a labor-intensive and time-consuming process, requiring domain expertise to ensure accuracy and relevance. How can the annotation process be optimized to support the training of NLP models in cybersecurity? The annotation process was optimized by leveraging semi-supervised learning techniques, where a small amount of labeled data was used to train initial models. These models then annotated larger datasets, which were subsequently reviewed and corrected by domain experts. This iterative approach significantly reduced the time and effort required for data annotation while maintaining high accuracy. Privacy concerns also posed a challenge in the application of NLP in cybersecurity. Analyzing large volumes of text data, particularly from social media and communication channels, raised ethical and legal considerations regarding user privacy and data protection. How can privacy concerns be addressed while leveraging NLP for cybersecurity? To address privacy concerns, the team implemented strict data anonymization protocols, ensuring that personally identifiable information was removed or obfuscated before analysis. Additionally, they adhered to regulatory guidelines and industry best practices for data protection. By maintaining transparency and engaging with stakeholders, they ensured responsible and ethical use of NLP technology. The project at CyberGuard demonstrated the transformative potential of NLP in enhancing cybersecurity. Through the integration of tokenization, part-of-speech tagging, named entity recognition, sentiment analysis, and machine translation, they developed a comprehensive threat detection framework. Advanced models like word embeddings, LSTMs, and transformers further enhance their capabilities, enabling them to analyze unstructured data with unprecedented accuracy. In conclusion, the application of NLP in cybersecurity is a game changer, offering powerful tools for threat detection and incident response. However, addressing challenges such as language variability, data annotation, and privacy concerns is crucial for realizing its full potential. By continuously refining their models and adhering to ethical standards, the team at CyberGuard set a benchmark for the industry. As AI and NLP technologies continue to evolve, their integration into cybersecurity will play an increasingly vital role in safeguarding digital assets and mitigating emerging threats.